Intel has always been a software company. Our business model and the scale that it requires means that we have to work with the whole ecosystem of software developers, sometimes years in advance of our products coming to market, to make sure that they're ready to take advantage of the features and capabilities we're putting into the chips when we launch a new product. Intel, I think, has a unique role to play in the HPC ecosystem because we are, on the one hand, the provider of and creator of silicon that goes into high-performance computing platforms. Secondly, we work very closely with the software ecosystem that supports and executes on those platforms. And then thirdly, we have a unique relationship with many of the governments and other commercial partners around the world that enable us to act as a trusted advisor, making sure that the industry is aligned, that they're following open standards, and that we're creating as much as a consensus as possible around high-performance computing standards, workloads, and implementation. In the software space, we have the Lustre file system, which is the world's leading highly parallel clustered file system for high-performance computing implementations. And then in the research and development space, we work very closely with universities and academic institutions around the world to help drive and accelerate the pace of innovation in the high-performance computing space. The work that the Datacenter Software is doing more broadly with Lustre and Hadoop and OpenStack is really based on creating a foundation in the data center for what will ultimately be the software-defined infrastructure vision and then the Internet of Things. And really what we're talking about here is having a flexible pool of resources both within the data center and within the public cloud space that are composable, orchestrated through software, reconfigurable on the fly, that take advantage of best-in-breed security, intelligence at the edge, and the ability to optimize for specific workloads. So ultimately, we expect you'll have smart devices and dumb devices at the edge, a fully configurable, fully virtualized network in the middle, and a software-defined infrastructure-based data center at the end that will take advantage of open standards and open source software to create an aggregated pool of capability that can be deployed, managed, and configured by an IT manager in any way that seems to suit the workloads that are being run at that moment.